Okay, so I told you I'd make a video about limits, so don't worry, I actually did. And so when we talk about limits in calculus, this is kind of like the first calculus topic that we're covering, and it's kind of a really abstract, like, topic. So a lot of the time in calculus or in math, right, up until now, we've plugged in an x value and we've gotten a y value out, and it's been fine and dandy. The idea behind a limit, right, is that it's the value that a function approaches, right? So as the input value gets closer to a specified quantity. So it's not that it's necessarily hitting that number, but it, like the y value, it's just as we get really, really close to an x value, we get really, really close to a y value. And what is that y value? So that's what the limit's saying, right? So the key word here is approaches. So it's not necessarily like hits that y value, it's that it approaches that y value when we're heading towards an x value. And then as we continue calculus, we will define what continuity is, derivatives, and integrals, and we'll know what all of these words mean. But limits are really that foundation, right? So when we talk about limits, we're really just talking about the y value we approach when we approach an x value. And as I go through examples, it will make more sense, hopefully, because right now I understand that it's a little abstract and it's not necessarily the most like solidified thing you've ever heard. Okay. So when we talk about limits, right, we have some not only notation that we have to pick up on, but we also have some like vernacular, some vocabulary. Okay, so calculus is kind of like a new language that we're learning together. We're gonna have a great time. So when we see this symbol right here, right, we have, we read this as the limit of the function f of x as x approaches c from the left, right? So I want to really emphasize that this negative sign, right, doesn't mean that we're raising it to a negative exponent. It means that the superscript, super means like above, right, sub means below. So the superscript is negative to emphasize from the left, right? So when we see the negative symbol, that means from the left. So we are evaluating the function, right, as we approach a specified x value from the left. Okay, and so when we see, right, that negative sign, that just means from the left. So then opposite, right, so you would think the opposite, if we're seeing a plus sign, right, that means from the right. So when we see this superscript as a plus sign, that just means from the right. Okay. So we read this as the limit of the function f of x as x approaches c from the right. And then when we don't see a superscript that's a plus sign or a negative sign, that just means as x approaches c, right? So it really doesn't matter from the left or right. We're just saying like as it approaches. And we'll talk more about what that means and what that looks like and how we use the left and right to determine what the overall, right, limit is at that x value. So the notation that I just want us to pick up on is the way we write it, right? So we write the limit, an x with an arrow, and then there's a value. That value in this case is c, but it will be a number, right, when we take the limit of something. The negative symbol means from the left. It does not mean like raised to a negative exponent. And then f of x refers to the function. So we're going to do a couple examples, and this will hopefully clear it up. Okay. So the first thing I want to point out on this diagram that we have a couple asymptotes, right? So this right here, this line, this horizontal line is a horizontal asymptote. And what an asymptote means is that that function will never, ever, ever touch that line, right? So this asymptote is at 3. So this function will never, ever, ever touch 3. So it will get really, 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 really close to y equals 3, right? but it will never touch it, right? So it will get to like 2.99999999999, like for infinity, but it will never get to 3.0, okay? So in this case, our horizontal asymptote is telling us that our y value for that part of the function will never hit y equals 3. So not only do we have a horizontal asymptote, we also have a vertical asymptote. And vertical asymptotes are a little different because what it's saying is that this function right here will never hit x equals 5, right? So it will go on in the y value for infinity, but it will never hit x equals 5, okay? So it will get to x equals 4.999999999, etc., right? But it will never, ever hit 5. Like the x value will never be 5.0, okay? So those are two things I wanted to talk about before we get started, and I'll go over them again as we go through. Let me just move my head down so you can actually see the graph. So the first thing we are looking at is the limit of the function f of x as x approaches positive, or sorry, as x approaches negative infinity. It's hard to see, right? But this is a negative sign right there. So when we're saying x approaches negative infinity is saying as x continues to go this way for forever. So as x goes more and more negative. And so as x goes more and more negative, right, it could be like negative 1,200, right? It keeps going this way. This is where a horizontal asymptote comes in. So if we are going in the negative direction of x values, right, this part of the function right here keeps getting higher, but because this is a horizontal asymptote, it will never cross y equals 3. So as x approaches negative infinity, the y value of the function approaches 3, but it will never hit 3. So we're just going to write 3, because when we talk about limits, we're not talking about what it actually hits. We're talking about what it approaches, right? What it gets really, really close to. Okay, so as x goes more and more negative, this part of the function will go up and up and up, but it will never cross the line y equals 3. And if it never crosses the line y equals 3, it only approaches 3. So the answer for the first limit is 3. So as we look at, and I'll choose a different color to kind of, keep it organized. So as we look at the limit of our function f of x as x approaches negative 5 from the left, right? So I care about this right here, this negative 5. And so if we're looking at it from the left, it comes in, right, really close to 1. So got a little messy there. I'll erase that. So if we're looking at it from the left, right, it's coming in to this point, negative 5, 1. So the limit of our function, f of x, as x approaches negative 5 from the left is 1. But if we look at it from the right, there's nothing over in this area right here, right? There's nothing there because our function splits up and goes below. So we need to look at the graph down here, right? So if we look at this from the right, right, if we're going from the right down, the limit of our function as x approaches negative 5 from the right is negative 2, right? Because as we're going down this way, right, it's getting really, really close to negative 2. So from the right, it approaches negative 2, but from the left, it approaches positive 1 because the function split up into 2. So this takes us to the next one, right? The limit of our function f of x as x overall, right, approaches -5. Well, if we're coming in from the left towards -5, we get a 1. And if we're coming in from the right towards -5, we get a -2. Well, 1 and -2 have never equaled each other in the history of math. There's never been a point where we've been like, 1 and -2 are the same number, right? They're different numbers. So if the left and the right don't match, and I'll write that over here. So if left and right don't match, then our answer is does not exist, right? Because -2 and 1 are not the same number. Right? Again, I want to emphasize that when we talk about limits, we're talking about the number we approach, right? If I plugged in -5 in this function, my answer would be 1. But it's not that I care about what the number we're plugging in is. I care about the number that we're approaching. So if we're approaching 1 from the left side and -2 from the right side, then we can't really be approaching the same number, right? Because 1 and -2 don't equal. And that's why for the limit of our function f of x as x approaches -5 overall, it does not exist because the left and the right side don't match up. So if I move on and I look over here, the limit of our function f of x as x approaches 0 from the left side. So 0 is right here. And our function approaching from the left side, right, it's getting really, really close to 4, and it hits 4. So as we approach 0, right, x equals 0 from the left side, or as we're approaching 0 from the left side, our y value is 4, right? So again, what we really care about is the y value that we're approaching, right? It's not the exact y value, but the y value that we're getting really close to. So in this case, it's 4. If we look at, right, our next one is the limit of our function f of x as x approaches 0 from the right side, right? So from the right side, again, we're approaching 4, right? They're going, like if we think about left going towards 4, right going towards 4, then overall, the limit of our function as x approaches 0 is 4 because our left and our right side match, right? Both sides are approaching 4. So we can say that as x approaches 0, the function approaches 4. So the next one we're going to move on to is the limit of our function f of x as x approaches 2 from the left side, right? So if I have 2 here, I'm coming in from the left side. My y value, right, is 0 because it's on the x-axis. So when we think about coming in, we really only think about the y value it's approaching because that's all we care about. And so it's approaching 0, right? As we get closer to 2 from the left side, we get closer to 0 on the y. And then if we think about 2, right, so now we're approaching it from the right side for the next one. So the limit of our function f of x as x approaches 2 from the right side. Again, same thing. You can think about it like we're getting really, really close to 0. And so because our left and our right side match, right, that means that our overall, as x approaches 2 for our function, it's going to be 0. And this is tricky, right? Because if I told you to plug in 2, right, so f of 2, well, f of 2, there's no point there. There's an open hole, but there's a point up here. So f of 2 equals 5. But when we're talking about limits, again, we don't care, right, what the actual point is. We only care about where we're approaching. So based off of looking, right, from approaching from the left at x equals 2 and from the right at x equals 2, we end up at 0. But if we actually care about that point, like if we want to plug in x equals 2 into f of x, then we'd end up with 5, right? Because that's where the actual point is, right? But we only care about where it's approaching. So if we only care about where it's approaching, then we go off of what we have, right? Our 0 and our 0, they match. So overall, the limit must be 0. I will choose this color. Okay. So then our last little section here, right? So now we're looking at the limit of our function f of x as x approaches 5 from the left side. And this is where our vertical asymptote comes in. So if we're looking at 5 from the left side, right, we have part of our function up there that keeps on going, right? The arrow means that it goes on for an infinite amount. So as we keep on going, right, it gets really, really close to 5 on the x-axis, but the y values will continue to go up and up and up and up and up and up and up for infinity, right? It goes on for forever. There's nothing stopping it. It just gets closer to 5 on the x-axis, right? But in reality, it will never hit 5, and it will just keep going up and up and up and like slide right next to that vertical asymptote. So when we talk about the limit of our function f of x as x approaches 5 from the left, we're talking about positive infinity, okay? Because the y values are going up for forever, right? So we don't know when they stop, so we use the idea of infinity, right, to represent that it goes on for forever. So if we look at the same function, right, but from the right, so now we're looking at as x approaches 5 from the right, we'll notice that we have a similar situation with an arrow going towards this vertical asymptote, but instead of being positive infinity, because it's going down into the negative y values here, it's negative infinity, right? So this will again go on for forever and get really, really close to this vertical asymptote line, but never cross it, right? It will never hit x equals 5. It will just get really close to 5. But the y values, because we keep going down and down and down and down and down, will go on until negative infinity, right? We don't know when they stop because the arrow, we just know that they go on for forever, right, in the negative direction. And so we represent that by negative infinity. So again, if we think about the overall, right, limit of our function f of x as x approaches 5, right, our left side and our right side don't match. And if they don't match, then it does not exist, right? Positive infinity and negative infinity are different quantities, right? One is positive and one is negative. So if they are not the same, then it does not exist. So our limit here is does not exist. Okay. And the last one we need to worry about is as x goes to positive infinity, right? So the limit of our function f of x as x goes towards positive infinity. And so the first thing that we started with, right, was when x was going towards negative infinity. So we cared about this side over here. But now we're talking about positive infinity. So it'd be like if these x values went on and on and on in the positive direction for forever. We don't know when they're going to stop. So if this keeps going, right, well, the only part of the function that's close is over here, right? And so this parabola will get wider and wider and wider as those x values keep going out towards infinity. And the y values of the parabola will keep going down towards negative y values, right? It just keeps going negative infinity. Again, like it just won't stop, right? It just keeps going down to negative infinity. So as our x values go towards positive infinity, right, this parabola gets wider and wider and wider, and the y values go more and more negative towards negative infinity. Okay. Hopefully this helped clear some things up. Watch this as many times as you need to. and you will get practice doing this. Do not worry about that.